everyone. I welcome you all to our amazing Azure AI Fundamentals Bootcamp. This bootcamp is going to be very amazing. This is Chavi, your host of the day, and this bootcamp will help you in upskilling your Azure knowledge, especially if I say specifically for AI 900 exam. So I hope you all are very much excited. I can see the excitement in the comment section that is happening right now, and we have a lot of developers who are just here to understand that how's everything is going to be. And so with that note, I welcome you all in our amazing today's bootcamp. We have a very special guest, we can say the expert speaker for our today's session, who will be taking you forward with everything. And also don't forget to join our Discord community, because we share amazing opportunities there. So with that note, hello Santosh, I welcome you to our amazing boot camp. How are you?
Hi everyone. Hope everyone is doing great and having a great evening as well. Yeah, pretty much
Yeah.
doing great and excited for the boot camp.
Exactly, amazing. So, Santosh is currently working as a data engineer at Cognizant, and it's been a long journey with Azure. To be honest, he has been contributing to Azure community from past various months, and also he's a very essential part of our community at the same time. So he would be taking you further with your AI 900 certification, whole syllabus, and a lot of stuff. So yeah, Santosh, the stage is all yours. And I'll be staying at the backstage. If you want any help or anything, you can just call me up, and yeah, we can just start. Thank you so much.
Sure. I think my screen is visible. Cool. I'll stop my video so that it doesn't interrupt any of the streaming issues that you might have.
Perfect.
Great. So with that said, so this is the first day, day one of the boot camp, and I hope a lot of people have joined in. And sorry for the delay that happened. So we'll start with the basics. So a quick intro of me and what I do. I work as a data engineer for Cognizant, and I have been taking boot camps for a year now for Azure developer community, and hold 6 certifications in Azure now, and Microsoft certified trainer for the second year, and have been pretty much active in Azure developer community and with Azure for the past 2 years or so. uh, yeah, super excited for this boot camp. And here are a few of the achievements that I've done in the past 2 years. And yeah, we'll get started on what we will be doing for the 3 days, today, tomorrow, and the day after. So we'll start with the basics of these five. Mostly today, we'll try to cover up all these, and we would have a hands-on, since nobody likes to have slides. So even I don't like have people show slides and go away. Something demo will always be something good. But today we won't be having a demo. Tomorrow I'll show you Python code, and the last day I would show you the machine learning designer, where you can design a pipeline without writing any. You don't have to even write a single line of code. So with that said, if you have any questions in between, drop it in the chat. I think I am able to see the chat as well, so I will be able to take up questions at the end, or we would have we'll take up questions in between as well after 30 minutes of the talk. So both way it works. Great. So how many of you are new, like brand new to AI or Azure, or don't have any experience with Azure? So just want to get uh, how many are familiar and how many are not, so that I could tone down or tone up the example levels and the explanation as well. We'll wait for 15 seconds for that to happen in the chats. I hope I could be able to see it. Okay, I think most people are freshers and pretty much new to AI. Okay, okay, new to AI, familiar. Yes, I'm a fresher. So, okay, cool. So we'll cater to new people who are like really fresh and new to AI. So why is AI necessary? So we'll start from the real basics of why or what is AI and what it does, and why people need it, and why it started booming, and why it is saturated now. So way back in 2018, 2017. So 2018 is my first interaction with AI or building models and having to do some predictions with the model, right? So at that time, AI was not that mature as of now. So now you have apps which can make your picture really clean and look good. But way back then, I don't think there was any AI which can do it. Now you have AI which can generate code from your comments, or you have doc strings and then it can generate code for it. So that is how the evolution has occurred. So we did have this MNIST data set, and it is a numbers data set from 0 to 9. So we classify the numbers, or we try to predict what digit it is. So that experiment has been done in 1980s. I did see a old video of it. I couldn't share it with you guys. Maybe tomorrow I'll do. So that was the first instance of me seeing machine learning in action. So it is a 24 cross 24 pixelated image. So it is a pretty simple image, to be honest, and it doesn't have any. It is just a grayscale image, so you have only deep blacks and whites. So it was pretty easy to process the image, and we don't have any processing power. So one of the greatest advantages that we have as of now is storage is becoming cheaper, and the data is growing exponentially. So every smartphone acts as a harvester of data. So every time when you turn on data, or even when you are not on your internet or mobile data, or you have connected with your home Wi-Fi, so what happens is all these apps collect data without it has it. You are concerned, you agree to use the app in the first place when you install it or when you sign up for any service. So you don't read any terms and conditions. You don't go through any of that, and then we agree to it. So everybody does that. Even I have done it. So data is becoming one of the greatest assets of people, right? So when people have data, they have now, let's say a small example would be uh, any app that you use, let's say Zomato or Swiggy or any of the food ordering apps. So that app can tell a overview of how Indians order food throughout the year, right? So they have all the data that they need, and they could also tell which part of Bangalore is eating more and which part of Bangalore is eating less. They know the address, they know how much they order and how much. They don't want to know the personal details, so that would be obviously separated from each other. But the overall picture you could get, right. So you have the data, you have the insight, you would have that insight of which part of Bangalore is consuming larger amounts of food, or who is eating more. So that is an interesting part. So why we need AI is another interesting place. This is the evolution, or this is a necessity, or is it like where the technology comes in and then you start adapting it and then you go with that? So I think is so there are different opinions from all these great people around, and I think there are two sides of the coin, right? So either it is good or bad. People use it for both, right? So you can easily write code, or you can predict passwords now. So usually we brute force passwords. Now you don't have to brute force anything. There are some projects which work on segregating your social data and then brute forcing the password, right? You obviously have what your date of birth, or your year, or for ATM pins, your 4 digit or 6 digit UPI IDs. So most of that is it is bad thing, and the good thing is where you use it for some kind of a healthcare related technology, where you can develop, where there are less doctors to serve people, and so countries like Africa, they don't have qualified doctors. They have only few handful of qualified doctors, and there are a lot of diseases that you have to identify. So those are the good places that, or the places that benefits the humankind in some way. So those are the benefits of having AI. and it is in all forms now. Even the thing that you see on YouTube, or the thing that you order, or the thing that you see on maps, or anything that you see now has some kind of an AI or a machine learning model has been incorporated inside that. Excuse me. So what happens when we don't have it, or when these get saturated? So as I said, 2018 is my first interaction. Uh, there it was pretty much difficult to understand what is AI, and we didn't have any resources, clean resources, clear cut idea, learning path, and everything. We didn't have Azure developer community for sure, and we didn't have any of the conferences that are happening, or at least I didn't know of, or I haven't attended it. So we didn't have any of that sort, and learning was difficult, and then you have to learn from the scratch, right? So you don't have any pre-trained models or any of that sort, or at least I haven't used it. But in 2019 and 20, things started changing a little. Uh, it is not it is not like a immediate change, or it doesn't occur in a night, but it was happening throughout the decade, and then the boom happened at the 2020 or 2019ish, where you have models for everything. So when I talk about Azure machine learning and its offerings, I would say it has almost all the use cases covered. So you don't even have to build models anymore. So everything is pre-trained. It is pre-trained and ready to use. So what you have to do is you have to spin up the model, you have to deploy that into a server, and then start using it. So that is the extent that we have come through, and Azure is doing a pretty good job with its computer vision APIs and NLP APIs, which we would see in its cognitive services offering. It is more of a necessity for an app to have some kind of AI these days. So nobody wants to, if there is a technology that can be helpful in some way, or it can enhance user experience, then why don't you use it? So most people are on that level of mindset, that if there is an AI, put it to use, whether it enhances experience by 20 percentage or 10 percentage or 5%. Let's say we would call it as this app as AI feature, or machine learning functionality to it. Great. So slides, you can read through it. I won't mind reading out the slides and everything. So the problem with most learning paths, or the most learners do, is they don't get the bigger picture. So they train the model, they deploy it, and then that is the thing that I did. So pretty much usually nobody said this is something that you have to do. You have to get the big picture, do that, do this. Usually, what we do is we train a model. Pretty much everybody uses Kaggle or Colab, or Jupyter Notebook is something that I use, and I have seen people using Spider for training model. That was way back, and now nobody uses it. People use Jupyter Notebook is something that evolved after it, and then we started using Kaggle and Colab for it. And we also have Azure offerings, Azure notebooks that you can use. That is one of the part that we would cover. So that is how the evolution has come across, and then we would see what are the different areas that AI has played a vital role. So the first part, for be easier understanding, what we would do is we would everybody know what is a stock, or at least have heard of stock markets and everything. You might have got calls from various people stating that invest in this, invest in that, and you would get good returns. So what if so you need a person with the knowledge of the maybe any industry that you take, maybe petroleum industry, or technology industry, or medicine or pharma. So any of that sort, you need a person with knowledge on the industry, and he has to understand the nuances. He has to understand what the company is doing, and what would be the projection of the value of each and every stock, and what is the company trying to achieve in the next 5 years. So all that you know he has to update in his mind and try to understand and get a good picture to invest in the stock. So that is pretty much how a human does it, right? But the machine can't, understand. The machine can't read from news articles. People are trying to do it, but for now, or at least for better understanding, I would put it in layman terms. So a machine can't do any of that sort. What a machine can do is, you give it 10 rows of data. So today the stock was high, tomorrow is low. It is too low for 2 days continuously, and it goes up on the third week, and it is a pattern. So this is a pattern that the machine learning model finds. It doesn't have external input. It doesn't, you don't feed. So let's say if a brand, if let's say if a brand faces a lawsuit, and then the stock price always goes down. So it doesn't have that knowledge, right? So there's a big brand, and then there's a big scam, and then the entire stock price goes down. But the machine learning model wouldn't know that, and it would keep predicting out that the model market is good and you can invest. So those are the things that we are still trying to develop, and we are trying to incorporate all that into a model. But for now, we haven't gone that far. So the far that we have went is finding the pattern and trying to predict out something, instead of, or you're trying to replace a human that has to do that particular work. It is more of an automation. It is a predictive automation, to be honest. So you predict something to the future, or you predict something, or you reduce the manpower, or you try to eliminate the manpower completely. So that is mostly what an AI does. Or this is the basic example of what an AI is and how it looks. And the videos that you see on YouTube. So it is pretty much an analysis of. So every video has sentiment metrics, and there are different metrics that they use to find if. So even if you're on incognito mode, or whatever private mode that you have in different browsers, uh, they know your IP. So based on the IP, they send you recommendations. Based on the country that you are in, they have a recommendation. So those are the recommendations that they give, despite you not wanting it, right? So we want, let's say you have subscribed to coding channels, and you are watching videos of that sort. Let's say you have subscribed to Azure developer community. So what you would get is all Azure content, or the at least on the top two grids. At least 4 or 5 videos would pop up on boot camp is happening, or starting now, or starting in 2 days, or starting in a week. Any of that sort would go into the picture. So that is the recommendation, or that is the role of AI. So what it tries to do is, you like this, so you might also like this one. So that is all machine learning model. So there are different types. We will cover it one by one, and how it is and what it does. And that is one part of it. And the screens that you see, your anomaly detection, uh, it, so these are some of the basic AIs that people use, and there are more deeper ones than this. We would cover that in the later slides. So yeah, and so there are two things to be understood. So if you're new to AI, so you have to learn first what how to build a model, how to deploy it, and the second part is where Azure comes into the picture, where how you implement or do the modeling with Azure Cloud Platform. So those are the two different things that you have to understand. So let's say you have the AI knowledge, you have built models, you have deployed it, but how can I efficiently do that on Azure? And what are the offerings that I have on Azure, which I can reliably use to scale the model, or efficiently deploy the model and reduce cost. So those are the aspects that you would see when it comes to Azure, and what how it is happening.
Hello, Santosh. Can you hear me? Santosh? Actually, your voice is not audible. I guess there is some issue. Can you please rejoin once because your voice is not audible from past few minutes. So can you please rejoin once? Till then, you can just have a look. Can you all hear me? Is my voice audible to you all? Perfect. So if you have any sort of doubt, you can just ask your questions in the comments below. I'll just have a look. Santosh, can you say something?
Yeah, I think I'm back. I
Yeah.
hope you can hear me as
Perfect.
well.
Actually, can you just have a look into the comments for once so that they can just ask the questions and then we can get started again.
Okay. So we can share the slides again. I think it is still shared. So any specific languages? Are there any prerequisites to learning AI? I don't think there is any thing that you have to learn before you start with AI, but it is a new tech and it is saturated enough, and everybody knows what is AI, or at least have some idea of what is AI, how you can build it in the first place. But so you don't need to have any specific knowledge, but having a knowledge of Python would be really helpful. That is one thing that you can definitely have any programming knowledge, but Python is something that you should definitely have for that. Great. We'll move on to the slides again, and then if there is any more questions, we'll come back to that at the end of the session. So, as we are talking about the risks and challenges that we have in AI, so we are running short of time again. There are around 20 slides that I have planned, and we have just this 11th one. But yeah, so first day we would get an idea of what is AI and a brief introduction on how things work and what are the things that you should observe, observe around. And then the third day would be more focused on what exactly the models are and the technicalities and the terms, the jargons. We'll get to that later. Great. So, as you have seen, there are loan approvals happening. There are automation cars that are taking the roads, and again, there are a lot of challenges that uh, engineers have faced, and they have solved it in different ways to make sure or ensure that AI is safe for everyone, but they can't guarantee 100% that this is good or this is bad, and not, I don't think there is a model with 100% accuracy, at least in a larger scale. So, with that said, there is always a risk factor involved in any place, right? So, loan approval doesn't impact anyone, right? If the loan is not approved by a single bank, the user or the customer can go to a different bank and get the loan. The the if, let's say, the vehicle crashes into someone, that is a serious issue to be considered. And let's say if you are prescribed a different, or you are diagnosed with a different disease, then that is again a risky one. And there are other use cases where it predicts out, dog for a cat and the cat for a dog, that doesn't harm us in any way. So these are the harmless AIs which doesn't affect us directly. But there are different, the first two examples, the loan and the vehicle, is something that has to be taken care of very seriously. Good. So Azure has these six principles put up for how you can build an AI or build a machine learning model on these six factors should be included when you build any of the machine learning models. So it is really important that they have come up with this. This has come up sooner. I think this should have been the case from the start. At least now it is a good start at that they are focusing on the things right now. The purpose, you create a machine learning model to support a loan approval application for a bank, and let's say the model has to predict whether or not the loan should be approved. And if let's say there is a bias between there could be an bias which is not let's say, since the human is not involved in any of the loan approval process. Let's say it is completely automated, so you submit an online application and then you enter all the details, and then it automatically detects that this customer is not eligible for the loan or he is eligible, right? There is no sort of any bias involved, and people were thinking that there couldn't be any bias, since human is not, and also humans have a tendency that if he's from the same state or he's from the same city or he speaks the same language, we kind of tend to, let's say you're going to a new place or you're going to a new town, and then you start things, or you just meet a stranger in the bus and they speak the same language. And then if let's say you have to give a seat to two people, and then one speaks the same language as yours and the another one doesn't, and you have an subconscious bias, or this time you have a conscious bias on giving to a person who speaks the same language, right? So that is something that we are trying to avoid with a machine learning model. So the model has they also have a bias based on the number of let's say there are 50 records of male applicants and 50 are female, so that is unbiased scenario. But if there are more male applicants or there are more female applicants for a single loan application or the model that you're trying to train, then the model would be biased on the side which has more number of training records. Reason, when you train a model, it tries to have different paths to achieve a single goal, right? So you have two classes, one is yes or no, it is 0 1 binary classification problem. It tends to give the probability of how much probability one or the saying yes to a person, and how much probability is saying no to a person. So the probability is based on how much data that you have fed to the model and how it is trained. So that would be the fairness, and there shouldn't be any of that case when you're trying to build a machine learning model. So these are the too much details into the machine learning or building models, but at least just know that these are there, and you have to at least have some kind of a knowledge on these principles before starting out or building any machine learning model. So reliability and safety, we have talked about that. Privacy and security, I don't have to talk about that. Everybody knows what is privacy and security, and how much data that you are giving out for the service that you are getting. Inclusiveness is again another a huge topic to talk about. Transparency is another area where when you're building a model, and then you should be really transparent that this is how the model is performing, and how you should understand the model, and how efficient that is, right? So what purpose the system was built, and what are the limitations that the model has, right? So those should be clearly mentioned when you're going for an industry grade application. That is really important. And the last part is another interesting part: accountability. So let's say a model fails, and whom to blame? The AI engineer, or the data engineer who fed the data, or the person who created the pipeline, or the entire team, or whom to hold accountable for if something goes wrong, right? So that is another area that what if there is a legal lawsuit against some model or a company, whom to blame is something another you know uh, area that we are still working on, and many companies are still working on clearly defining what should happen if something of this sort occurs again or occurs for the first time. So that is pretty much the accountability part of it. Great. So this is something that we have covered so far. It is just a recap of all the things. We'll quickly jump onto the next things. So what we have seen, what an AI, what it does, and his history of it, and now we would see the different types of machine learning models that you might see in your day-to-day basis. And we'll try to put it into buckets of how good or how bad it is, or which category that they belong to. Okay. So as I said, the first, if you're sticking around till now, hopefully I've seen the first part when I spoke about finding patterns, right? So let's say you give the data set that you see on your screen to a person to classify, or segregate flaws, right? So what a person or a human thinks is different from how an AI goes about. No, it AI only cares about the data and what data to fetch, or it is more of a user or someone giving you the data and trying to force you to choose between this one. Let's say pretty much the AI would give the petal size, the shape of it, and how tall it is, how broad it is, and what color it is, maybe if it is a colored image. So all these are data that are given by the human or by someone, by the ML engineer into the system, and it trains or it is restricted or it is constrained within those boundaries, or it can only use those features whatever the user has given to the model. It can train only with that, but the human has no. Let's say someone could interrupt that it is blue, everything is blue, and there are only a few flowers which is blue filled, and others are only just the outlines of it. Someone would classify based on the number of petals that it has, or someone would classify it as how many loops it has. So these are different interpretations for a single image, and humans are really good at interpreting one thing in a different way or in any number of ways. Cool. So what you do or what a machine learning model does is kind of finds a path or a pattern between the class. Right? So it kind of compares uh, one with another, and then it tries to find what exactly the pattern it is. Cool. So this one is pretty much similar to this one, but it is blue filled and it is filled, and this is a different shape of it, or it is a mirrored image of this one. But for a human, it is pretty much easily distinguishable from this one. This is simple mirrored image, but the shape and everything is the same. But it tries to find some kind of relation. So it could be anything. It could be the shape, size, or any parameter in that sort, and then we try to find or predict it. So let's say you give, you show that. So once you train the model, so there are three, basic phases in machine learning or building a model. Is where you collect the data. So that is the data cleansing, cleaning, or the that portion of it. And then the second part is the exact training. So that is would be the second part. And the final one would be deploying it. So we would cover the first two, or maybe we'll more focus on uh, how you can train a model and how it is trained and what are the things that you can do to train it. We wouldn't see any of data cleaning, or we'll also see the deployment at the end of the or at the day on day three. Great. So this is another example. So the first example that we saw is something called as classification. So what, how different that is from this is, so you have, you are classifying different objects, and there are only fixed number of outcomes, right? So you know that you train five different class, and you could only get five different. Or if, let's say, you show the machine learning model a different flower which you haven't trained, then there wouldn't be any possibility of you getting the flower which was trained. But again, the model can tell you that this is similar to some similar. This percentage similar to the flower A that you have trained. So if you, let's say, flower A to E, and then you give a flower G to the model, and predict out which, classify which flower it is. It won't give you the exact result, and it is obviously wrong to give the exact result, and you can't expect flower G to be classified since we have trained it from A to E. But again, it can give you the probability of G being similar to A to E, right? So it can give you that particular probability, and it won't classify it, but again, it can give you the probability. Great. Another most common machine learning part is regression. So I spoke about the stock market part. So it is a regression problem. So once you train a machine learning model, you can give it any number of years, and you can give any data to it, and you can try to predict the stock price. The problem with that is, now what we have seen so far is training a model, and then using it for a long time. The another factor that has arisen is frequently retraining the model, right? So you may not, you have a startup, and then it grows up, and you have trained a model, and then you're using it for a long time, and then the company is growing, and everything is going good, but the model is still the old one. It could give you only the older results. Or if there are less number of employees, let's say, for a company, and then it has grown up to 10x, and if you don't feed the 10x value or update the 10x value and retrain your model, it would still be an older model, and it won't give you an accurate result or the result that you would expect. So that is the problem with having to have only the model trained once and used for a long time. And this is true when you have real time problems such as stock market prediction, and there are cases where you have medical use cases where you have to retrain the model pretty often to classify similar disease types or cancer types, for an example. So those are the common things that you should understand before starting out or start working on regression models or any models for the reason. So this is another common example. We can go through this one by one. So we have the temperature and the number of cycles. So pretty much what happens in the first stage, the data cleaning or the data validation, or the data, we usually clean out data in the first stage itself to limit the number of, extract the number of features that we need. So in this case, we have just two. So what we'll try to do is we'll split. So why do we need to split? So it is the same as why we need test in the first place. So instead of just reading the book and just going off, what you do is you have a validation step. So the data that you see over here, this won't be given to the model for training, right? So what you do is you take bunch of data and you hide it from the model being trained, and then you try to validate the model after it has trained with all these data and check if it can give you the exact result. So this is the result that and you are trying to give the model the data which is not being used for training, and then you are trying to predict out the value. Cool. So this is the number of this is the temperature and the number of cycle has been given to rent. You could consider it of any sort. What we are trying to do is we are plotting the temperature and the cycle rentals in a XY plot, and then we are seeing what exactly the value is. So let's say it should be mostly an horizon, or it shouldn't be an exponential line. So obviously it won't be. uh, but some cases there are outliers, but in this case we have values or data points closer and together. So what the regression model tries to find is the number of data points it can cross with a straight line. So that is mostly the case, how this regression part is trying to train itself. So what we try to do is, we do have a formula for calculating what exactly would be the outcome. So let's say you know 100. What you do is you try to plot it in the graph, and then you hit. So let's say temperature is 40, and what would be the exact number of cycles rented. So let's say you want to buy more cycles for rent, and then you want to say you're a owner of a cycle brand, and then you want to see if I have to buy more cycles or less cycles for the next quarter. So that is a real business use case that anybody could have. So that is what you are trying to predict. And as you can see from the graph, so this is pretty much a basic example. But once you start implementing yourself, it would be more clear, instead of just showing you the formulas and how it is calculated. So this would be the deviation and the difference. I don't want to get into too much technical in the first day, but so this would be the line that you draw. So the line could be as straight as possible. It is obviously y is equal to mx plus c. That is the formula that you use for the line, for drawing any line in a 2D graph with x and y axis. And this is how much difference it from the straight line. So this is the optimal line that you are trying to draw, and how different is the data point is moved, or how much distance is the data point from this particular straight line. So that is one data point that we are trying to use. So this we wouldn't touch a classification. We'll go for a classification model in this date tomorrow. I'll show you the machine learning designer, and we'll go through that particular phase. But this is a rough example of how a regression model trains and looks like. Great. So this is again a classification problem. So the first classification problem that we saw is with images, and these are with numbers. So So let's say if medication is needed or not. It might be any data set. For an example, we'll just have four values or the four labels that you're trying to predict, and we still do the same for classification. But in this case, we know the feature values or labels. You can call it any of that. So these are jargons or the terms that you should use, maybe in your interviews, or when someone is asking how you learn, um, how you have used machine learning, or when you talk about machine learning about your model. You can use all these terms. So these are some of the technical terms that you should definitely use when you're trying to, you know, maybe showcase your project on a hackathon, or maybe to your professors in college. So any of that, make sure you so first day you won't get all these, and it is not like 1 hour you will learn everything, and I'm rushing through things as well. So obviously it takes time. So it takes around 6 months to be. It won't be, if you dedicate 2 hours of your time or 1 hour of your time, it will take around months. But if you sit on a Saturday and Sunday, so the problem that you shouldn't be doing is sitting on the entire day and learning from A to Z. So that won't be useful. You would forget things a lot initially with machine learning, or at least for me it was of that sort, but eventually you will get up to speed, but it takes time. So sigmoidal function or S-shaped curve or the function is something that you would get for 0 and y. So the probability would increase. So this is a zero point 0.5 or 50% probability. If it goes above 50, it is probably a S, or it goes below 50, it is a no. This could be for any problem. For in this case, it is diabetic patients or not. So what we try to predict is what probability it is and how much probability this can take. So the probabilities, it can be let's say it can be one, since it has 90 percentage probability, and it can be zero since it has 70 percentage probability for zero. So this is a binary classification again, when you have just ones and zeros to it. So again, these are the terms that we would use when you're trying to plot the confusion matrix: true positives, true negatives, false positives, false negatives. So those are the four terms that will come up to once we train a model, and then we'll try to navigate through it. To explain in a simple term, so this is a true positive means the value that we know that this patient is not diabetic, and the model also gives you the same value, and that is true positives. And when that is not the case, then there's a mismatch between let's say you say that model is uh, the patient is not diabetic, and if the model falsely classifies that patient as diabetic, and that could be another case where the model says he's diabetic, or the patient is really diabetic and the model says he's not. So those are the two places where you could go wrong, or the model could go wrong for any of these. Great. So, so this is how the confusion matrix looks like. So it is the predicted versus the actual value. So these are the random numbers. So it doesn't mean anything. So it is the number of true positives that you could have, and that is one of the so probably these two are the diagonals that you should look up to. So predicted is also zero and the actual is also zero, so these two numbers should be small as possible, and the diagonal, the main diagonal should be as high as possible. So that means that it gives you it can the model can give you good results. So we are running short of time again. So the first example that we saw, we could also use that for a clustering example. So the classification is example for the image processing. Let's say you want to classify this image and this image, but this same image can be used for clustering. So clustering is nothing but grouping of items. So let's say you give 100 flowers and you try to group them by any features, right? That could be a smell, that could be the color of the flower, that could be the number of petals that it has. So all these parameters goes into the play of how much this could be any feature. So any feature, for example, could be used for grouping of these flowers. So what happens is you should give the number of clusters that you need as per your convenience, but it would give you the similarity between. So this is the data point that we have, and it moves when more and more data comes into it. Let's say you feed this particular data and it moves closer to this point, and then it forms a group around this point. So that is how this particular thing rolls out. And talking about how you can do this particular inside Azure, that is where we have Microsoft Azure Machine Learning, or Machine Learning Studio, it was called earlier. So Studio was a good name though. So these are the things that we have. So for anything that you do on Azure, you need a valid subscription. So you could get Azure for Student subscription if you have a valid university email address, which is associated with Azure or Microsoft in any way. So most of the universities are. So you could give it a shot of getting a free subscription for for a year. You can use that. After a year, you should definitely use a credit card to get a pay as you go subscription. But at least for a year, you get all the uh, most of the services free, and you also get $100 credit if I'm not wrong. So you can use them to play around inside Azure. So these are things or the services that we have. So subscription is the first part, and then you have the ML workspace. It has all the compute data, experiments, models, and services. So experiments is where the actual training happens. We'll see that when we use the machine learning studio. So it is called machine learning, and the thing that is inside is machine learning studio. That's the name. Name doesn't matter. Designer is another name. Pretty much people use when you use the designer part. So the final part we'll close it in another 5 minutes. So if you have any questions, you should hold it up tomorrow. So we'll take up questions at the start of tomorrow's session, and then we'll start the actual one. Great. So this is another interesting part of Azure offering. So earlier we used to give data, and then we used to give labels, and then we used to write Python code to create a model. That was the usual case. Now what Azure has abstracted it is, uh, so you just give the data to us. We would train the model. We'll pick out the best model that this possibly could have, and then we will try to use that. So you don't have to do feature engineering. You don't have to have any engineers working around. So at least for the data, for the model building part, so you just give us the raw data, or at least some data cleaning has to be done before giving out to Azure. So what happens is you just give the data, and we would take care of everything after that. So till the model deployment, you can automate the entire process. So whatever the model you want to get, how many hours you have to train, all these you can give, and it takes care of everything else except finding the best model that can. So again, it is mostly useful for experimenting, and mostly the industry use cases trying to find which model is really capable of handling the particular data that you submit. So there are different aspects of how the data looks like and what model to use. There's a relation between the data type and then the data and how the data looks. So let's say there are binary classification and there are multi-class classification. So all these examples, few models outperform others in a few of the areas. So it would find the best model for your data set and for the labels that you're trying to choose. So this is a quick look on how the designer looks like. So we'll do this designer part at the last day. Tomorrow we'll show you Python code of how the cognitive services are used and how you can use cognitive services and play around with the computer vision APIs. And yeah, so it's that's it I had for today. So yeah, so we'll see the demo tomorrow since we might not have the time for it. But yeah, so pretty much we are done with the session. If you have any questions, we'll take up two or three, and then we'll wind it up. So I'll wait for 2 more minutes for questions to come up, or we can take up questions tomorrow at the start of the session. Anything works. Otherwise, we could close out the session. We can see you guys on tomorrow's session. Okay, great. I think you don't have any questions. That means two things. One, you have understood everything, or you haven't understood anything. So I take it in the first one, you understood at least some part of it. So the first day it won't be too much useful, or you won't get everything in 1 hour. Well, I completely understand that. I have even been there. So
Thank you so much, Santosh, for such an amazing session. And I'm pretty much sure everyone also loved the session. We can see the response on like all the comments. And there was just like few things. And yeah, you can just reach out to him over LinkedIn. Okay, he is very much active there. You can just you can just reach out to him if you have any sort of doubts. That would be really great. Okay, for the doubts and everything. And again, thank you so much, Santosh, for such an amazing session. It was really great having you. And with that note, thank you so much, everyone, for joining in as well.